Python is the backbone of everything cool in Gen AI right now. But let's be real for a minute. Installing and managing a Python project is hard. It's like marrying 100 different tools which just don't want to play nice together. I mean, you have to install your Python versions. You'll have to make sure you have a way to manage your dependencies. And don't even get me started on the Jupyter Notebook madness. It's just so frustrating. But what if I tell you there's a way to skip all of that and just code? Yep, that's exactly where UV comes in. And today we have a guest who's been in the Python ecosystem for 15 plus years to teach us what UV is and what it can do for us. So, thank you so much for joining me, buddy. Okay, it's time for me to introduce you, right? So, Prashant Rao is an AI engineer from Kuzu. He's got 2 master's degree, like in aerospace engineering and in computer science. Best part is that he's super deep into the data and AI ecosystem. And there's just so much to learn from him. So talking about UV. So UV, from what I understand, again, I don't come from the Python world at all.
Yep.
Right? You've made a lot of fun about me because of that. But before you get into like the UV specifics, I have a little generic question because see, whenever somebody introduces developer tooling to say that, okay, I'm going to make your workflows better, I'm going to make your experience better, it's very important to know what's the ideal experience like. So for you, what is the ideal experience? What is UV trying to achieve?
Makes perfect sense. Yep. Okay. So like most developers, I'm extremely lazy. So
All right, fair enough.
the main thing I want from my tools is it should make my life as easy as possible. And ideally, I need to use the fewest number of tools possible to do my job, right? So historically in Python, if you've worked in Python as long as I have, you know that that's not the case. You know that the Python ecosystem is incredibly fragmented, and for good reason. It's partly because Python is a really old language. I think it's pretty old, older than pretty much everyone watching this stream.
That's not a good thing to say right now.
I know, right?
You didn't hear that, guys. You didn't hear that.
To highlight why I'm so bullish on UV and why I love it so much and why I think it's so important for Python developers everywhere to know about it is what are we looking for from a package manager or a tool that integrates with a programming language of choice. For me, there are a few key characteristics. There's performance, where the tool helps me run code as fast as possible. That is, you spend the minimum amount of time, waiting for things like environments to be built and code to execute. Right? So that's a performance angle. Then there's a portability angle where if I use an environment on my Mac and you have, I don't know, a Linux machine and somebody else is using Windows, the same code that I run should equally run on the other machines. There should be no change of workflow required on your end or someone else's end, depending on the operating system that you're using. And this ties into the next point, which is reproducibility. So the code that I run or write should produce the exact same results on my machine as they do on yours or anyone else's machine. That is, nobody who takes my code from GitHub or anywhere else should have trouble reproducing my results. And I think this leads into the point of ease of use, where you want your tool to just be so easy to pick up and get going with so that you can bring up to speed, I don't know, new developers, junior developers, or your colleagues who haven't heard of it yet, like what I'm going to do today, basically, right? I'm going to show how easy UV is to use and how amazing it is because the tool is so well designed.
I'm not a Python guy. I don't think I'm in love with Python either. But what does it say about a tool? If the best part about it was written in another language.
Welcome everyone, and this is the UV 10x package manager demo. So for everyone who's kind of new to Python or has heard of other package managers like Poetry or Pip or whatever else people are using, I think I just want to quickly go through some of the highlights here in this docs page of UV, because I think it very succinctly summarizes why I care so much and why the Python community cares so much about UV. The idea here is it's an extremely fast Python package and project manager. And part of it is that it's fast because it's written in Rust, but it's fast for many other reasons, not just the fact that it's written in Rust. But the key thing to note is in this first point here. The philosophy behind UV is that it was designed to replace an entire suite of other tools in the Python ecosystem. And it does this while also being 10 to 100x faster than any existing alternative out there. So the idea behind UV is that it installs and manages your Python versions. So you don't need to have a base or system level Python installation beforehand. You can ask UV to install and manage Python for you. The idea here is UV does all of the other things as well. It It can be used to run your applications in a project format or in just simple scripts. The most important thing it does is project management using a universal log file. I think this is again a very important thing, which is it ensures portability across systems. The other beautiful thing about UV is it has a pip compatible interface. So if you've come from pip, UV will be just a walk in the park. It's just like a breeze using it. You don't have to really rewire your brain to think differently. Of course, it's fully platform independent. You can use it on Mac, Linux, and Windows. So it doesn't matter what you or your colleagues are using. It's pretty much universal across all systems. Yeah.
So I'm just wondering. So I understand that for dependencies, you wanna lock the versions, right? Almost every language kind of does that at this point.
Absolutely.
I'm curious to know, like, did you ever require or have the need to get different versions of Python installed? Because like so far, I just do an apt-get install and that's pretty much it. But do we need multiple versions at any given point of time in Python?
Yeah.
Is that
Yeah.
a
So again, I feel like the more you work in a large group of people, I think in especially organizations where you have legacy projects, new projects, senior developers, junior developers, like a diverse set of people with a large number of projects, it's inevitable that certain projects will be written in older versions of Python. And as you know, Python is a language that keeps evolving, right? It's never going to be static, like no language ever is static. So new syntax comes in, right? For example, I think Python 3.10 introduced the case statement or the match statement or something like that. I think that's similar to case statement. So there's been completely new syntax being introduced in certain new versions. So it's not exactly backwards compatible. So in certain cases, you may have to potentially upgrade your code, or code that you ran on an older version of Python may not work in the newer version, and so on. So it can help to have multiple versions of Python on a single machine.
Got it.
So I'm going to be starting off by, actually, you know what? Let me first open an editor window. So I have this. Yeah.
That's a really interesting question. Oh, yeah, you know what? Let's take this question up right now. I really like this question. So Ashaya just asked us. So we understand that, hey, dependency management, managing the Python versions and stuff like that is really important for application development, like the app layer or the application level concerns that you deal with. But whenever you're working with running a model or model development, like for example, if I wanna run Llama CPP as a library, right? And Ashaya, I think he says that okay, anything CUDA related needs conda, because I mean he's right. Poetry just doesn't work in those cases. So and you need to do a pip install so you don't get a virtual environment. Does UV help for those kind of use cases as well?
So as far as I know, I don't know about the CUDA related situations, because those are very, very specific. And there's a lot of compiler dependencies there, C++ and all that crazy stuff. So
we should try.
I wouldn't say that that's the primary use case for which UV was built. I would more think of UV as application developers' best friend. Like I think what Ashaya just mentioned, right? Like model development may not be the primary use case for what it's designed for. Yeah, what I'm trying to show here is on my left side of my screen, I have a very basic directory structure. I have this file main.py. It's a simple Python script. And I have this data set of CSV files. And it's basically information or data on movies. And let me just explain what I'm actually modeling in the data set. If you know me well, or if you come to know me well, I'm a huge sci-fi fan, and my all-time favorite movie is Interstellar. So basically my goal here is to use a simple demonstration of, think about this Wikipedia page of Interstellar. We have the initial, summary description of what the movie is. Then you have a plot description of the movie. And then you have structured fields like this, which is the data about the director, the producer, who wrote it, other things. And then you have more structured information below. If you look at a high level, I'm just going to zoom out here, data set here that is quite rich, right? And it's meta in the sense that when you want to actually ask questions about this data set, you can't just naively, generate vector embeddings of this as is, because there is a meta model sitting one layer above the actual data. Basically, what I'm showing now in my example data set is I have all these CSV files. So I have a bunch of things related to actors, characters, let's look at the movie names. So in this case, I've only taken Christopher Nolan movies, so Interstellar, Dunkirk, and Inception. And I've used the summary fields from the Wikipedia pages as some of the metadata for this. Each of these has a 1 or 2 sentence description talking about what is in the movie's summary. As an initial point, let's say you're tasked with developing a RAG application on top of this data set. as a developer, the first thing you'd want to do is get familiar with the data, right? So the first kind of you could say task that you're modeling or doing is the exploratory task, like an exploratory data analysis. And typically when you do this kind of work, you're doing this in an interactive environment. You're not doing this in Python scripts or like a project structure. Yeah, so I'm using Polars, the data frame library, to read the data from these CSV files and kind of check what's in there. I'm just running the simple filter query where I say, okay, give me all the movies that were released before the year 2015. In reality, you might have something more complicated where the data is not clean. So you might have to do things like transformations and fix things with the columns and so on.
Essentially, we're trying to just explore stuff. We've got some data and we're writing a bunch of Python scripts just to figure out what the data is, what's happening, and run a bunch of commands to make sure it's just working.
So this is where UV comes in, right? You would want to use like a package manager that has dependency management baked in, and you would want to segregate this into a virtual environment so that any version of Polars that you use here does not conflict with any other version of Polars you may be using in your other projects. The last thing you would want to do as a Python developer is install Polars in your base level of Python, like in your base installation. You want to have a virtual environment that segregates the dependency only into this directory and nowhere else in your system. That was a bit of a background as to why we are going through all of this. Now, I won't run the code straight away, obviously, because I've not installed the dependencies yet. A typical project, you would have something like, I don't know, a README file. You would have, I don't know, your script files, git ignore, and the data itself. And you would typically commit only like small files to GitHub. So this folder that I have here kind of mimics what I would have on GitHub. The way you would distribute version or dependencies across any project to other people is, in the old way of doing things using pip, you would use a requirements.txt. In Poetry, you would have its own way of doing it. If you're using Poetry, you would have poetry.lock and a bunch of other files related to it, like a pyproject.toml and so on. Each way of dependency management, each tool that does dependency management in Python has its own way of distributing version numbers. So the simplest and easiest way to do it, at least for most people who are kind of working across different operating systems, tends to be requirements.txt files. So, and this is how a typical requirements.txt file would look. Now, in this case, I don't need so many dependencies. All I really need is Polars. Let's say I want to use a bunch of features in Llama Index as part of the initial graph construction state. In reality, you could have a lot of complicated dependencies here that themselves have many sub-dependencies. If all we are doing is just running a single import, great. You don't need too much complexity. You can just do a simple pip install Polars and you're done. But I think the real world is something more similar to this, where you have dependencies within other dependencies, and those can potentially lead to conflicts, or you need a good dependency resolver that can actually detect these conflicts in a way that you're able to safely and, you could say, easily install this environment on your machine to start executing the code. So what I want to demonstrate next, a simple demo of how I would install this using pip, like the old way, and then do the same thing with UV, the new way, and show how long that takes. And then compare the ease of use and user friendliness. If you've used pip, I think this is how you would normally do things. If you're in a virtual environment, you need to know that you're in the environment, right? Like if you're using Conda, you'll see base by default, but then you'd see the name of the Conda environment alongside the rest of your terminal. So the idea here is, by default, you're made to think in terms of virtual environments, right? That's how Python has made you think all these years. So the way you start doing something like this is you run a simple command like python -m venv. So this is using the venv virtual environment manager in Python. This -m in Python is basically just running like a script that is kind of calling a bunch of other utilities.
But the key thing, to be honest, Prashant, is how many people in chat actually create virtual environments?
So the idea is, now that I've created the environment, you'll notice that nothing has changed in this first line of my terminal. Right? I don't see any virtual environment shown. But so what I need to do to actually be in that environment is I need to run another command, source. So I need to say source.vn/bin/activate. And this is basically another script within this .vn directory that I just created. And that is what activates the virtual environment. Now, once we are in this, we can actually run pip install. And what I'll do now is, because I've activated my virtual environment, I would run the standard pip. Actually, I'll run a time command before this. So pip install. So what pip has to do now is it actually has to resolve these dependencies. Like Llama Index has its own set of dependencies. Kuzu has its own set of dependencies. Polars has its own. So everything in this might have its own sub-dependencies that may conflict with one another. So it creates like a dependency graph, and it has to resolve that graph to ensure that there are no conflicts. So
Well,
that's what pip is going to be doing.
Installing one package doesn't mean you're just installing one package. There could be like 100
Exactly.
different packages. It depends on, which depends on other things. So yeah,
Absolutely.
it's a big maze.
And
It's a big
this
maze.
is not necessarily a Python specific thing. It's true for any language. Python's ecosystem is so gigantic, and there are a gazillion libraries. There's always going to be chances that one library may conflict with another. Dependency resolution is a very difficult problem. It's a graph problem, coincidentally. So what I'm trying to do here is I'm going to time the overall wall clock time it takes to run this dependency resolver that pip has under the hood, to actually compute the dependency tree for this, and then check for conflicts and get my virtual environment installed in a way that I can begin running the code. So I'll run this, and you'll see now it's doing a bunch of downloads because it doesn't have all the dependencies locally. So it's fair. I mean, some of these have to be downloaded on the fly, collected all the required dependency packages, and it's doing something under the hood now.
Right.
So basically you'll see here, wall clock time is about 23 seconds end to end. Now, let's see how to do the same thing with UV, right? So what I'll do is,
how much time will it take?
I mean, go for it. I'll like give it a shot. First, let's clear our UV cache. So I'm just going to use UV clean cache.
Let's make it fair.
So now I'm starting afresh. So this VN from pip is no longer useful. I'm just going to get rid of that entire direct. Now with UV, the thing is, UV prefers using a pyproject.tom. Right now you can see here, I don't have a pyproject.tom, right? Because let's say you came from Poetry or some other ecosystem. All you had was knowledge of the high level or top level versions of each of these. So it's pretty easy to create your own requirements.txt by hand. In this case, I actually created this one by hand. In this case, it's quite easy to use the same information for UV as well, but we won't directly install it using UV. The command UV needs is you need to first initialize by project.toml. So we basically have this command UV init, right? When you type UV init, you're initializing your project, and it creates an empty pyproject.toml. As you can see here, there's nothing in here with like the dependency list is an empty list. So our job here is to populate this pyproject.toml with the information from requirements.txt. Now UV allows you to do this in one step. You populate this as well as install all the dependencies in one single, and the line for that is UV add -r requirements.txt. So you're telling it again, recursively go through the requirements.txt file, and the UV add command will essentially not only install it, but it will also add it, that is append to the pyproject.toml that already exists. What was that, 23 seconds? So you're saying it's like 3 to 5 seconds roughly?
Yeah, sure. Let's go with, actually let's make it 2 seconds, because it's got to be better than that, right?
Let's,
Wait, what?
there you go.
That's not even a
So-
second.
and this is with a cold cache, by the way, so there's nothing in the cache. If I run it a second time and a third time, you'll notice that it's pulling from the cache, so it's pretty much instantaneous, right? Like when you're running multiple projects side by side, UV is so insane that you can't even think before the command executes. Like you've literally barely typed the command and then you already finished doing your task. From what I understand, UV does not download things from the PyPI official repository. They've created their own mirrors, and they've parallelized the downloads from those mirrors. So in some ways, you're obviously benefiting from their own builds of this whole thing. But that's not the only thing. What's happening is you can notice here, UV very, very quickly resolved these 90 like you can see here, there are 91 sub-dependencies within the total tree that I have, right? And it's taken just 140 milliseconds to resolve. It's collecting all the sub-dependencies, right? And then kind of designing the dependency tree and double-checking the graph and verifying that there's no conflicts. And the execution of that step is the fastest step here.
Right.
The reason pip is slow is not because of the download alone. It is slow because the dependency resolver is slow. Right? So there's a lot of very, very clever Rust optimizations that have gone in the design of UV. And actually you can see a lot of YouTube talks on UV. There's one specifically by Charlie Marsh, the creator of UV, where he talks about some of the optimizations that they put in. Like it's totally worth a watch, and my God, like it just blows your mind how amazingly smart these people are who've come up with these techniques, because it just like 1 second saved, actually not 1 second, in this case we saved 23 seconds in our execution time. You could do the same with Poetry, just as a reference. Do you want me to go through the Poetry example as well, just for clarity? Yeah. So actually let's ignore the Poetry thing for now. We can look at it when we do yours. The point I can show here is, okay, we see the pyproject.toml got updated now with the correct versions that I have for my requirements.txt, right? So the UV command updated this file. And then the second thing is it created a uv.lock. This is the most important thing. The lock file is quite large. It is machine generated, not to be touched by hand. So It's something that you would never touch, but it's something that gets generated every single time your dependencies update. If you really take a quick glance at what's happening in this log file, you see for each and every dependency, but that's not the only thing. You also have independent URLs for each and every wheel file, that is the underlying binary that is used to install the dependency, each and every operating system that they compile for. So the reason this exists in the log file is because this has to be platform independent, right? So let's say I did my work on a Mac OS ARM64 architecture, and you do your work on a Linux. So the log file contains the correct URL that your machine would need depending on the version that it asked for. So essentially, it's pre-compiling and pre-storing all this information so that the log file has all the necessary information for you to distribute your code to anyone else using whatever operating system they might be using.
Right.
So this is how it ensures reproducibility and you could say portability. Now, this hello.py file is something it just creates by default. It's just a simple main function with a main block. You don't need to use it. What I do is I normally end up deleting it moment it's created because I anyway like to write my own code from scratch. But the point I'm trying to make is, yeah, you see here, even in the pyproject.toml, UV actually wrote the version of Python. So if I understand Toml's syntax, correct me if I'm wrong, Nuren, but the greater than equal to here just means because I'd use 3.12 on my machine, that's why that's what's being stored in the pyproject.toml. So this is kind of what you would distribute and commit to GitHub so that somebody else might know what version that you worked with.
Got it.
Let me go back to my main.py, right? So I have my virtual environment installed. So let me open a terminal. I have just these few lines to execute. I'm gonna have a data frame. I'm gonna have whatever. Let me do basic print commands. Go ahead. So I just have two print commands to display the outputs of what I'm doing. I'm just reading in a CSV file from movie.csv and then printing the outputs. So normally I would run this using Python main.py. Now this is fine. It runs the code. I'm able to do it. Okay. You know what I might have done? I might have made the same mistake that I normally do, which is I don't know whether I'm in the environment or not.
Exactly.
Let's try that again.
Yeah, it wouldn't work. Exactly. You have to activate the environment.
Good catch. Very good catch.
Oh, absolutely.
So you're absolutely.
Oh, I'll find points to this on Python. I mean, I'm all for it.
But the good news is UV takes away the stress, right? I do UV Python install. I've already done this command before. I have UV Python install 3.12. So UV downloads its version of CPython for me, and it installs that and manages that for me. Having done this, I can then do a UV Python list and use this argument only installed. So what this does is it shows me a list of all the Pythons that I have on my machine. And this is crazy, right? Like every machine will have multiple versions of Python somewhere in some way or form. Like if you're on Linux, you'll have a system installation as part of your operating system because part of the command line utilities and Unix systems rely on Python. So in this case, this lowermost entry here is my command line tools in my Mac. Thing with Python is you always might have that concern, which Python am I running when I type Python, right? Like right now it says, okay, it's running 3.12.7, but how do I know where that Python is coming from? So what people normally used to do is you should type which Python as a command, and it would tell you that, okay, it's using a particular global Python, right? In this case, it's using whatever, pyenv version of Python. That's what it's telling me because I had set pyenv to be my globally accessible Python. So all this being said, UV does not care about any of this, right? I know I have a version of Python installed by UV. So to run code in UV, all I would do is I would literally just use the command UV run, which replaces the Python command, specify the name of the script, and you'll see now that UV ran that code. So UV is using whatever version of Python it has, and it's running the same code that I have. Why did it run even though I did not activate a virtual environment, right? Because UV is smart. Like UV sees there is a venv in my directory. It sees a .venv here. If there was not a venv, UV is even smarter. It would actually use the PyProject and uv.lock and automatically install the virtual environment for me, even if I forgot to activate the environment.
UV run, technically what it does is it sees what's the current pyenv. It sees whether the dependencies listed in the PyProject is installed or not. If not, it will install it before running the command itself.
Yes. We can test this out really quickly. Best practice with UV is always keep the uv.lock and the pyproject.toml. These are the two most important files it needs. Requirements.txt is not necessary. It's
you
just
can delete it now, right?
I'll keep it there for reference purposes. But yeah, it's not really used by UV. What UV uses are these two, right? So now we can just run the same command again, uv run main.py, and you'll notice it used a version of CPython and it created a virtual environment at .venv. It again installed the thing in
I
217
don't, I don't
milliseconds.
understand how can it do it so quickly. Oh my god, this is crazy.
It installed and ran the code in that time. It's just crazy. Let's say you forgot to install Python. Let's say you didn't even have, I don't know, PyEnv or any of the other things that I use, right?
Sure.
UV would even download Python for you. So
What?
if you did,
Okay.
if you just ran UV run main.py with nothing, like you don't have Python, you don't have UV, you have not, except UV, you have nothing else.
Right.
It would basically look at your PyProject.toml. It would see this line requires Python greater than 312, and it would download its version of Python 312 for you, then install the virtual environment, and then run the code for you. So you basically need to just lift your little finger. That's all you need. You don't need to do anything more than that.
Actually, when I saw your presentation, you were doing some magic stuff which seemed like a
Absolutely.
Jupyter notebook, but it wasn't a Jupyter notebook. So yeah, let's talk about the notebooks part, because I know a lot of people when they're starting with Python, they're actually using notebooks.
And I'm going to create a new pip-based virtual environment.
Like
So
I
I'm just
think
gonna-
we can skip the
yeah.
dependency management part now, because I think we already understand how that works.
Yeah. But the reason I'm doing this is I want to show the old way of doing things in a way that
Oh,
relates
yeah.
with how UV makes this so simple. Yeah, so I'm just going to reactivate this pip thing again. Now, the old way I used to do things, and I'm sure a lot of people who have worked on Adobe exploratory tasks using notebooks or Jupyter notebooks, is you would use like a virtual environment, and you would use, I don't know, pip install Jupyter Lab or something like this. So you would install a local environment version of Jupyter Lab on this virtual environment. Again, look how long it takes. It would take a few seconds. And once this is done, what you would do is you would have a .ipynb file. You can see here on the left side of my screen. So I have example.ipynb, which is a Jupyter notebook file. And to run this, I would just run Jupyter Lab from this terminal window here. And it would basically create. So I would open it using this interface here, random thing EDA for movie dataset. And I have these cells, right? And then I would run these cells. Again, you'll see the same problem, no module name polar. So what happened is I think it's loaded the environment from, actually, I'm not sure why that happened. This is always the problem with Jupyter notebooks. You kind of are not sure which version of environment it loaded from. But anyway, assuming we fixed this and we ran each of these cells, there's an immediate problem now. There is a disconnect between the code that I ran. In this case, I have some data frame outputs that I have here. The code in my notebook is not directly transferable to someone else unless they also do the same thing that I did, which is install a Jupyter Lab, open the notebook, and see what is in there. So this is a fundamental problem with code share and reproducibility and people being able to replicate other people's workflows.
Right. And just to be clear, chat, I mean,
Yeah.
if you're one of those people who's just using pip install globally, which again, we're looking at you, don't do that.
I'm genuinely concerned for your safety. Please don't do that.
We're concerned for safety. Oh my god, okay, we're concerned for your safety. You might get fired for that. Okay, no, I'm kidding. But if you're doing a pip install globally, you're not gonna see those issues we're trying to highlight, but you shouldn't be doing that anyways. The moment you get into virtual
Absolutely.
environment territory, every time you run Jupyter Labs, you'll have to make sure that you ran it in the right environment, and then
Exactly.
Jupyter itself is loading the right kernel from the right environment. It's just like virtual environments and Jupyter Labs just don't like to work well together.
It's always been like, I've been working in Python for years, more than 10 years, and I still get confused at times. I'm not sure whether I've actually activated it correctly.
Oh, yeah.
I can't even imagine how it feels for a new person who's never used a language before and is trying
absolutely.
to run scientific
And
code or whatever it is.
I think Jupyter Labs, these guys have written some code specifically to make sure that it never loads correctly whenever you're doing the demo. It detects a demo
You're
and
spot
it
on.
stops working. I don't know
You're
how
right.
did they figure that out, but every time you're doing a demo, it just stops working.
Oh my god, I ran this code before and it worked. You're spot
I know.
on.
I'm telling you, they have written. It's a feature. It's not a bug. It's a feature.
It's true. So what I'm going to do now is demonstrate how beautifully simple it is with VS Code, UV, and I'll show what IPyKernel is. I think the right command for this is UV sync. There you go. Yeah. So you can just run UV sync. Let me type that in again. SYNC. So UV sync will look at the local pyproject.toml. So let's say you cloned someone else's GitHub repo and you want to start running their code. You would just run UV sync and it will automatically do all the right steps. It'll just basically create a .venv. All my environment is set up and configured and I'm ready to go. So now that I've done this, I need to be able to run code interactively. And now VS Code and even Cursor, these are both editors that have interactivity baked in. You don't really need a Jupyter notebook anymore. So let me demonstrate how I do this. I add this package called ipykernel. So it's basically the IPython kernel that is the same underlying tool at the base of Jupyter. What the VS Code people have done is they've taken the IPython source code and embedded that into whatever they're doing in here. So I'm not sure about the exact implementation details, but essentially you can run code in your script as though it were a Jupyter notebook. So what I'm doing here is I'm using this command uv-add, which is basically adding a new package, but I'm using the --dev flag here. So what this means is I'm only installing the ipykernel package in a development environment. If somebody else were to run uv-sync on their machine, they would not install my dev dependencies. They would only install the main dependencies. Does that make sense?
Wow. So
I'm just
UV has first-class support for dev dependencies as well.
Exactly. So let's
That's
look
really
at the
good.
let's look at the pyproject.toml now. You have a dependencies tree list here. You don't have ipykernel here. It's only in the dependency groups called dev. So if somebody were to just run UV sync, it will only look at this portion. It won't look at the dev version of it. Yeah.
The sync doesn't install the dev dependencies. But then,
Yes.
like if I'm cloning the repo, but I want the dev dependencies, what do I do then?
I believe there should be a command UV sync dev or something. Again, you'll have to look at the docs for that.
You can do UV sync group dev or something like that.
There you go. Yeah, there is a flag that you can do to install
my
dev.
bad.
Yeah. So you can always do that. It's not like an issue. It's just people generally don't want to install dev dependencies because it clutters their overall environment. So yeah, now that I've done this, I basically have a .vn with everything I need from my requirements.txt or pyproject.toml, and I have ipykernel now. So what I can do is I can literally just go to my script. Like I have a main.py script. I don't care about the ipynb anymore. I can pretty much delete this thing. So I look at main.py and I can literally select, like highlight lines here like this and do shift plus enter. And as always in a demo, things fail. Okay, so let's see what's happened here. That's strange. Yeah. That's strange.
I mean,
Why?
That's a Python problem.
It's not a Python problem. Okay, so this is
It
again,
is a
as
Python
always,
problem.
live demos fail. This is just by default, it will select the local environment. That's not an issue. I don't know what the hell happened here. It should not happen. That I think it was because I was messing with all the other things that this happened. This is how it normally behaves. Like if you're using VS Code, it's the exact same behavior. The moment you click these two lines, select these two lines and highlight them and press shift plus enter, depending on your operating system, I think it should be the same. You will run those two lines of code. Now, where it gets interesting is I don't need print statements anymore. I'll show why. Like all I need is individual line execution. So I'll read the movie data lines here, and I will also run this data frame read command from Polars. Right. So now I've run this line. The data frame object is in memory now. It's actually in this interactive session. Double click on this variable here and shift enter just the variable. Basically, without a print statement, I'm able to introspect the state of intermediate variables, like you would in a Jupyter notebook. So even in Jupyter notebooks, by the way, you would have had to use like this additional line, df, and then done a shift enter there to run it. Here, the benefit is because it's an interactive editor, you basically have the luxury of using the variable name itself to just directly output this in the UI that you're going to show the results on.
Got it.
So this is really powerful because now if I have a bunch of things I'm running, I can very easily just run individual lines of code and show specific results, check the intermediate state. Like in this case, movies before 2015 are these two, right? The amazing thing here is all of this was a script file that I would have distributed to my end user. If I'm actually working on a larger project with multiple people, I would essentially save a project structure with Python files. Some files inherit from other files. So with all of that complicated structure, I can pretty much interactively execute code that I would not edit. It's pretty much in the state that it would be for the final, I guess, production scenario or cases where you might actually share this code with someone else. And the argument that people have regarding Jupyter Notebooks is that it's a literate form of programming. So your documentation is right next to your code, but you can pretty much write with things like cursor now, you can pretty much just add a hash symbol and it writes the comments for you. Like it's just crazy how good code itself.
One thing cool about Jupyter Notebooks, which I have to give it to it, is when I was creating some YouTube videos on some of the like AI stuff, Jupyter Notebooks really gives me a good way to commit the results of every step, like the answers in the notebook itself, and then commit it. So like GitHub will render the answers in the notebook without anybody having to clone and run it themselves. I remember I made a video on predictive autoscaling, and then I had notebooks. And now if I open a notebook with GitHub, Come on, don't fail me here. Yeah, you see this? My
Yep.
notebook is right here, and the output of certain steps, like if I want
I
to
get
plot
it.
a graph, it's
I get
right
it.
here
Okay.
without anybody having to run this.
The idea here is think about what you're trying to do end to end. Go from an idea to code that runs and executes the idea in a way that you're able to solve a problem, right?
Right.
That's what UV is helping you solve. It's actually helping you go from an idea to a result in the shortest time possible with the least number of tools and least amount of effort.
All right. So there are some questions and some
Yep.
really, really interesting questions. I mean, I love
Awesome.
that one. But before that, guys, I just want to remind you that I put in the link to Prashant's code in the chat already. And of course, if you're interested in stuff like this and you want to just be a part of the conversation even after, and you want to help me even decide what goes on stream, you really need to join my Discord. Ashay just asked another question. I think Ashay is like, okay, you know what? I've got Prashant. I'm gonna squeeze him for every ounce of wisdom he has. But the question is, in theory, you could have a Docker file with just some base image, like a generic base image like Debian or Ubuntu, and make sure just UV is installed in it, and that's it. And obviously, and your source code. But you don't have to really worry about running UV install or UV sync to build the image. Is that true?
I'd have to verify in terms of how efficiently UV downloads Python within a Docker image depending on the network environment that it's in. But you're spot on. I mean, the time spent in downloading Python, installing UV sync, and getting the environment up to pace is nothing. So in CI, you're pretty much spending like less than a second doing all of this stuff, and immediately your CI starts focusing on the actual task at hand. So it creates much slimmer binaries, and I'm pretty sure people are doing some really smart stuff with this in CI.
It seems like you should, in theory, be able to do it, right? So the answer is yes, you should be able to do it, like Prashant also validated. However, just because you can do it doesn't mean it would be a great idea to do it. The reason being, especially like if you're thinking about scale, you want to make sure that there are no vulnerabilities in your code. You want to make sure that Python version, which was there, has no reported vulnerabilities. If you're installing things like Python on the fly, first of all, you need an internet connection on your environment, which is not always possible. Which I think Prashant already alluded to. But more importantly, if there's a reported vulnerability in like an old version of Python or in 3.12, which you're using, and the latest one has fixed it, there is no way for you to know that, okay, you know what, somebody just reported a vulnerability. There was another question by PSI Legends. What a name, PSI Legends. I use Conda a lot. Is UV like the new Conda? Sorry, I joined in late. You just want to summarize that really quick for us, Prashant? Is UV like the new Conda? Just a really quick. I think it's a good chance to even summarize what we just saw.
Yeah. So I think, in summary, UV is one-stop shop for everything related to Python package management and project management. So it not only installs Python dependencies, but it also manages Python versions, syncs your dependencies, allows you to share those across different operating systems in a portable way. And of course, it's very, very fast. So I would say it's a bigger, like a broader version of Conda. It's not just a package manager. It's much, much bigger than that.
I think that was pretty good.
We covered a lot of stuff, but I'm hoping at the very least UV is communicated that UV is an easy tool to get started with. I don't see any reason why people should think that it's intimidating. Just get going. It's like literally a few lines and you're on your way. Hopefully it was useful. And if anyone has questions about UV and things like this, you can always reach out to me through whatever platform you prefer.
Thanks once again, Prashant. Thanks for your time. I really appreciate it. I'll be calling you soon. And thanks for introducing us to the world of UV.
Sure. Thanks to all the people who joined as well.
Alrighty. Bye-bye. So guys, I hope you guys liked it. I think that was a lot of fun. I think inviting a guest was a lot of fun as well. Do join the Discord server because all the next stream and discussions is gonna be on there. So I want you guys to start suggesting some of the topics that we'll be covering on stream. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am YourTechBud. You're on YouTube and hopefully in real life.